ఫోన్ తీస్తుంది.
ఒక నిమిషం పని ఏదైనా పని.
Good evening to all. Am I audible? Okay, then let us discuss the numerical problems, few numerical problems on second order system. So this is the question. Certain measurements were conducted on a servo mechanism which show the system response as C of t is equal to 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t when subjected to the unit step input. So there is a servo mechanism. There is some servo mechanism. Okay. When certain measurements were conducted. Okay. And when input is given, unit step input is given, the output, the response C of t that is obtained is this. So input, unit step input is given and response for that unit step input is also given. So what we have to determine is find expression for closed loop transfer function. So we have to determine the expression for closed loop transfer function. That means we have to determine the transfer function. That's it. Okay. So and obtain the undamped natural frequency and damping ratio of the system. So undamped natural frequency, that is omega n. Damping ratio is zeta. So we have to determine omega n value and we have to determine zeta value. Okay, we have to determine omega n and zeta value and also transfer function. So I'll give you a minute. You just write it down. You just note down this question in your notes. As soon as you complete, please inform. Okay then. So what is the data that is available in the question? Input, unit step input and output is available in the question. So let us take the output C of t. Okay, this is our solution. Okay. So what is given? Output is given C of t is equal to 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t. Now let us take the Laplace transformation of this above equation. So Laplace of 1 is 1 by s. So Laplace of 1, you will get 1 by s. 0.2 is constant, leave it. Laplace of this e power minus 60 is 1 by s plus 60 and minus 1.2. So 1.2 is constant, leave it as it is. Laplace of e power minus 10t is 1 by s plus 10. Okay, it's simple. So simply take the Laplace of the above equation. You will get 1 by s plus 0.2, 1 by s plus 60 minus 1.2, 1 by s plus 10. After that, now take the common denominator. What is there in denominator? S plus 60 and s plus 10. Take the common denominator. After taking the common denominator, you just simplify it. So if you take the common denominator, so you have to multiply this one. Okay, so you will get 1 into s plus 60 and s plus 10 plus 0.2 into s into s plus 10 minus 1.2 into s plus 60. Okay, so it's taking common denominator. How to take common denominator and how to simplify the equation? It's a very basic question. It's the basic knowledge of mathematics. If you don't know that, you just search in the Google and you will get some idea how to take the common denominator and how to simplify the expression. Okay, it's very simple. Even it's that knowledge you must have at the 6th standard itself. Okay, so I hope if you are unable to understand how to take the common denominator and how to write this expression, you just go through the Google and search how to write it. Okay, after that you just multiply all the terms in the numerator. Whatever terms are there, you just multiply them and you just expand the expression. You will get s square plus 70 s plus 600 plus 0.2 s square plus 2s minus 1.2 s square minus 72s divided by s into s plus 60 into s plus 10. Okay, so here after expanding the whole expression, I have taken s square term common. So if you take s square term common, so you will get s square into 1 plus 0.2 minus 1.2. And I have taken even this s term common. So if you take s term common, you will get s into 70 plus 2 minus 72 plus 600 is a constant term. Just write it as it is. Okay, divided by s into s plus 60, s plus 10. So if you have completed, please mention that you have completed in the chat box so that I will proceed. You just note it down. If you have completed, mention in the chat box. them. Now whatever terms are there besides to s square, you can see all these are numerical terms. You just add them. 1 plus 0.2 minus 1.2. Okay, and here I think they will cancel each other, isn't it? 70 plus 2, 72 minus 72. Here 1.2 minus 1.2. So this whole term will become 0. This whole term will become 0. Okay, so what is left over in the numerator? Only 600 will be left over. Okay, so if you see here, I have written it, isn't it? I have written here in this slide s square into 0 plus s into 0 plus 600 divided by s into s plus 60 into s plus 10. So what is left over? 600 by s into s plus 60 into s plus 10 is our C of s. Okay, so this is our C of s. So response in Laplace. Now what is our input? Unit step input. What is it? R of t is equal to 1 is our input. If you take the Laplace of that input, what do you get? R of s is equal to 1 by s. If you have completed, please inform. Okay then. What did they ask us to determine? They have, first of all, they have asked us to determine the closed loop transfer function. So we have an expression for C of s. We have expression for R of s. What is C of s? This is C of s, isn't it? 600 by s into s plus 60 into s plus 10. I will write it down. Wait, I will write it so that it will be. Wait. So this is C of s divided by R of s. What is R of s? R of s is 1 by s. Something is wrong with my mouse, or I don't know why. So I thought it is better to write C of s and R of s so that it will more easy. It will be more easy for you people to understand. So one more thing I wanted to do. This is it. So if you observe here, what is it? Closed loop transfer function. We have to determine the closed loop transfer function. So what is C of S? C of S is this term. This is C of S term. What is R of S? This is R of S term. So C of S by R of S. Okay. So here this you can rewrite it as what? The C of S into S by 1. 1 by S can be written as this. Instead of writing it in the denominator, you can write it as S by 1. This S and this S will cancel. So what is left over? 600 by S plus 60 into S plus 10. That is our closed loop transfer function. Okay. This is our closed loop transfer function. Okay. Now this is it. One term which they have asked us to determine the closed loop transfer function. We have determined it. Now what did they ask? They have also asked us to determine the undamped natural frequency and damping ratio of the system. So undamped natural frequency is omega n. Undamped natural frequency is omega n, and damping ratio is zeta. So this is omega n, this is zeta. So now to get zeta and omega n, what we have to do is, you have to take the transfer function, just now whatever we have got here, and compare it with the standard form of your second order system. So what is the standard form of your second order system? It is C of S by R of S is equal to, what is the standard form? Standard form is C of S by R of S is equal to omega n square by S square plus 2 zeta omega n S plus omega n square. So compare whatever we have got the transfer. What is our transfer function that we have got? 600 by S plus 60 into S plus 10. Okay. Compare this with the standard form. Okay, so for that what you have to do is, this denominator, you just expand the denominator. S plus 60 into S plus 10, if you expand it, what do you get? S square plus 70S plus 600. Okay, this is what you are going to get. Now you just compare these two expressions. Just compare these two expressions. If you compare these two expressions, so what you can observe here is, in the numerator, you just see here, this is omega n square. This is 600. This is omega n square. This is 600. Okay. So what is meant by 600 now? What is meant by 600 now? 600 is nothing but omega n square. So omega n square is equal to what? 600. Okay. So omega n square is 600. And one more thing, this 2 zeta omega n is the coefficient of S, isn't it? 2 zeta omega n is coefficient of S. Here 70 is the coefficient of S. So 70 is equal to what? 2 zeta omega n. Okay, 70. Okay, 70 is equal to 2 zeta. I can't write zeta. I will try 2 zeta omega n. Okay, this omega n, 2 zeta omega n is equal to what? 70. Similarly, what is omega n square? Omega n square is equal to omega n square is equal to how much? Is equal to 600. It is equal to 600. I will write 6 once again. I will write 6 once again. This is it. This is it. So what you have to do to determine the damping ratio and undamped natural frequency, you have to take the standard equation of your second order system and you have to compare it with the transfer functions that you have obtained from the given data. Okay, so when you compare those two, you will get the coefficient of s in the denominator is it will be equal to 2 zeta omega n, and omega n square, that is 600. Omega n square will be equal to this numerator term. Okay, now omega n square is equal to what? 600. So what is omega n? Omega n is equal to root 600. What do you get? If you take the root of 600, you will get 24.49 radians per second. Okay, so we have got the omega n value. Now we have to determine damping ratio. So what is damping ratio? What did you get? Coefficient of S 70 is equal to 2 zeta omega n. What is zeta? 70 by 2 omega n. 70 divided by 2 omega n. Zeta is equal to 70 divided by 2 omega n. What is omega n value? Just now we are determined. What is omega n value? Omega n value is 24.49. Omega n value is 24.49. Okay, substitute omega n value in this formula. 70 divided by 2 omega n. You just substitute, you will get zeta is equal to 1.49. Okay, zeta is equal to what? 1.49. You just write it. As soon as you complete, you just inform me. I don't know whether I have given sufficient time to write this. If you want me to go back to previous slide, just mention in the chat box. Otherwise, you just copy it down. You just use your calculator to determine. That's it. This numerical problem is over. We have determined omega n, we have determined damping ratio, and we have determined the closed loop transfer function. So first of all, we have to determine the closed loop transfer function. Then only we will be able to determine the undamped natural frequency and damping ratio. I hope you have completed. Let's go to the next numerical problem. If anyone have any doubt, you can mention in the chat box. I will clarify that. So I hope you have understood the first numerical problem. Sure. Okay, so here another numerical problem is there. So in this numerical problem, what you can see, we have to obtain the response of unity feedback. So I'm sorry. One second, wait a minute. Hey, fast करो. सर ये तो उठ रहा. टिश्यू.
Toilet paper. ముందు తినాలి కదా.
इससे पड़ेगा ना कुत्ते हम पढ़. Okay. Okay, this is the numerical problem. Obtain the response of unity feedback system whose open loop transfer function is g of s is equal to 4 by s into s plus 5 when the input is unit step input. This is the unity feedback system. So it's a simple unity feedback system. You can see R of S is the input and C of S is the output. Forward path gain is G of S and feedback gain is H of S. Okay, here if you observe in the question itself, they have clearly mentioned it is unity feedback system. That means H of S is equal to 1. G of S is given. G of S is equal to how much? 4 divided by S into S plus 5. Okay, 4 divided by S into S plus 5 is the G of S and H of S is equal to 1. Input is what? Unit step input. Means R of S is equal to how much? 1 by S. Okay, R of S is equal to 1 by S. G of S is equal to 4 by S into S plus 5. H of S is equal to 1. That is it. You just note it down. As soon as you complete, you just mention the chat box so that I will proceed further. So we can solve this numerical problem. So I hope you have completed. So now, what is given? G of S is given. Of course, H of S is also given. That is 1. It's my cursor. Yeah. Given G of S is this. H of S I did not write. If you want, you can write it here. H of S is equal to 1. Okay, you can write it here. So to determine the transfer function is equal to C of S by R of S. Okay, so that is equal to what? It's a negative feedback system. Is it negative feedback? You can observe here it is negative feedback system. Therefore, transfer function is G of S by 1 plus G of S H of S. Transfer function is 1 plus G of S by 1 plus G of S into H of S. So H of S is 1. Okay, H of S value is 1. So even if you won't write H of S, it doesn't matter. So what is our transfer function now? G of S by 1 plus G of S. What is G of S? 4 by S into S plus 5 divided by 1 plus G of S is 4 by S into S plus 5. Okay, so just simplify it. If you simplify it further, you will get 4 divided by 1 plus S into S plus 5. Okay, and here S into S plus 5 is there. Just multiply it and you should get S square. You should get S square. This is S square. It is not looking like S square. Okay, so this is what you will get. S square plus 5S plus 1 you will get. Square plus 5S plus 1 you should get. I think you have further simplified it. 4 divided by 1 plus S into S plus 5 means S square plus 5S. Yeah. S square plus 5S plus 1 So you just determine the factorial, or you just determine the factorized form of this s square plus 5s plus 1, or you just determine the roots of this s square plus 5s plus 1. You will get s plus 4 into s plus 1. Okay, determine the roots of this denominator term. You will get s plus 4 into s plus 1. So what is our transfer function now? Transfer function is equal to 4 divided by s plus 4 into s plus 1. Okay, T of s. This is T of s. Okay, it's simple. If you have the minimum knowledge of mathematical simplification, you can determine the transfer function. Otherwise, it will be difficult for you to simplify the expressions. So you just complete it. I think okay, whatever. This expression, just check this expression. It seems something is missing here. So here it is 4 divided by s into s plus 5. Here 1 plus 4 divided by s into s plus 5. So s square plus 5s. Okay, so 1 into s square plus 5s plus 4. So earlier whatever was there, it was right. Something is wrong. Here some term, I think I have missed some term here. Please check that, and you just check it, and if whatever express term that you will get, you just inform me in the chat box. I think I have missed something. It is s square plus 5 plus 4, not 1. Yeah, that's it. I think this is 4. This is 4, not 1. That is it. Here also it is not 1. Okay, some term has been missed here. I didn't notice it. So you just observe here in this expression, in this third expression, if you observe here, this is the denominator. 1 plus 4 by s into s plus 5 means s square plus 5s. So if you take the common denominator, you will get s square plus 5 plus 4 whole divided by s into s plus 5. Yeah, s into s plus 5, s into s plus 5, they will be cancelled. What is left over is 4 divided by s square plus 5, 5s plus 4. Yeah, this is it. It is not, it was not 1. Okay, so some modifications, I don't know how it happened. Okay, so then now it is correct. Okay, you just solve it. If you have the basic knowledge of solving the expression, you will do it. So since while typing instead of 4, I think I have something, this square term, it became 2. Okay, while copying and while just copying and downloading terms, positions change. Okay, so we just confuse it. So this is s square plus 5s. Okay, so I think this is correct. So 4 divided by s square plus 5s plus 4. You just determine the roots of this denominator, you will get s square plus 5s plus 4. For that you will get s plus 4 into s plus 1. That's it. So I have wasted enough time here because of this terms were somewhat mismatching. That's why some of the time has been wasted. Oh, it's okay. So this is our transfer function now. So what is our transfer function? T of s is equal to 4 divided by s plus 4 into s plus 1. That is it. Now we know the input. What is our input? I hope we have written. So what is our input? Your input is the step input. Where is my cursor? Okay. So if this is our step input, what is it? R of t equal to 1. In Laplace it is 1 by s. So if we determine the, okay, of course we have to determine the transfer function. We have already determined. So what is our C of s? C of s is equal to R of s into T of s. So what is T of s? T of s is equal to 4 divided by s plus 4 into s plus 1, and R of s is 1 by s. So C of s is equal to 1 by s into 4 divided by s plus 4 into s plus 1. So C of s is, this is R of s, this is T of s. Okay, R of s and T of s. So the response in S domain. This is our response in S domain. Now let us determine the response in time domain. In the question, what did they ask? They have asked us to obtain the response. That's it. They didn't mention anything else. So response in time domain we have to determine. So we have the response in S domain. So we have to determine the response in time domain. How many terms are there in the denominator? S, s plus 4, s plus 1. 3 terms are there. Let us go for the partial fractions. Okay, so if you go for the partial fractions, you can easily determine the response in time domain. So I am going for the partial fraction. So by partial fraction expansion, C of s is what? 4 divided by s into s plus 4 into s plus 1. So a by s, b by s plus 1, c by s plus 4. So a is equal to what? Output into s at s is equal to 0. So what is our output? 4s. Is it 4s? It is not 4s actually. C of s is what? 4 divided by s into s plus 4 into s plus 1 into s. Into what? Into s. That into s, instead of writing into s, I have written that s here. Okay. Now this s and this s, they will be cancelled, and substitute s equal to 0. So after cancelling that, I might have written one more expression. I didn't write here. After cancelling s, substitute s equal to 0. What is left over? 4 divided by 4 into 1. 4 into 1 means 4. 4 divided by 4, a is equal to 1. Okay, I have skipped one step here. You people, you just add one more step and write it down. So a is equal to 1. Yeah, whoever have written the expression, it is correct. Yeah. So some mismatching terms were there because I downloaded and after that I edited the whole PPT. So because of that, some terms have changed. So that's why I just rechecked the expressions. So that's it. A is equal to 1. Did you complete? I hope you have completed. Now let's determine B. B is equal to what? C of s into s plus 1 at s is equal to minus 1. So what is C of s? 4 into s, no actually it is 4 divided by s into s plus 4 into s plus 1 into s plus 1, here it is. So instead of writing into s plus 1, I have multiplied with 4. So C of s into s plus 1, I have multiplied the numerator terms. 4 into s plus 1 by s into s plus 4 into s plus 1. So now what you can do, you can cancel s plus 1, s plus 1. What is left over? 4 divided by s into s plus 4. Substitute s is equal to minus 1. So here minus 1, here minus 1. So what do you get? 4 divided by minus 1 into minus 1 plus 4. So minus 1 plus 4 means minus 3. Plus 3. Okay. So minus 1 plus 4 you will get plus 3. 3 into minus 1 you will get minus 3. Okay. So 4 divided by minus 3. You can rewrite it as minus 4 by 3. So that is our B value. Now what about C? C is equal to C of s into s plus 4 at s is equal to minus 4. So you just multiply these two. What do you get? 4 into s plus 4 by s into s plus 4 into s plus 1. So s plus 4 will be cancelled. So what do you get? 4 divided by s into s plus 1 at s is equal to minus 4. So substitute s is equal to minus 4. You will get 4 divided by minus 4 into minus 4 plus 1. Minus 4 plus 1 is minus 3. So this 4 will be cancelled. So minus 3 into minus 1, it is plus 3. So 1 divided by 3 you will get. C is equal to 1 divided by 3. B is equal to minus 4 by 3. A is equal to 1. Okay, that's what you will get. So just write it down. As soon as you complete, please inform. So I will conclude this topic within a minute. Now substitute all this in your partial fraction expression of what? This expression. Substitute A, B, C in this. Okay, here A, B, C terms are there, isn't it? Substitute A, B, C in this expression. You will get the output in Laplace as this. This is the partial, after partial fraction, this is our output in Laplace form. So what is it? Response in our Laplace form. C of s is equal to 1 by s minus 4 by 3 into s plus 1 plus 1 by 3 into s plus 4. Now take the inverse Laplace transform of this above expression. If you take the inverse Laplace, what is inverse Laplace of 1 by s? 1. So 4 by 3 is constant. So 4 by 3 into 1 by s plus 1. What is the inverse Laplace of 1 by s plus 1? E power minus t. Okay. 1 by 3 you just take it as constant. What is it? 1 by s plus 4, what is it? E power minus 4t. So this is our response in time domain, C of t. Okay. So they have asked us to determine the response. We have determined the response in time domain. So whenever they ask us to determine the response, we must always determine the response in time domain. That's it. So you just take a minute, you just write it down. That's it. Today's class is concluded. If anyone have any doubt, you can mention in the chat box. So I hope there are no doubts. These two are very small and very small numerical problems, and here if you have the basic knowledge of simplifying the fractional terms, and if you have the basic knowledge of partial fractions, mathematical knowledge, you can easily solve the numerical problems. Only one thing that you must know is the standard form of second order system. That expression, if you remember, you can solve these two numerical problems. For second numerical problem, I think we don't even require the standard form of second order system. Why? Because they didn't ask us any undamped natural frequency or damping ratio. They didn't ask us in the question. Therefore, no need of second order standard form expression. Okay, for this second numerical problem. So that's it.